want to do a video for you of how you can graph a parabola when it's not quite in your standard form, and it might even involve some completing the square. So let's get started by recognizing it is a parabola because we have one variable only squared, the y variable. And to get this in standard form, we would typically begin by getting the squared term on the left side. So I'm going to move the y squared term to the other side, along with any other y terms. And it looks like I even made a copy error here. It should have been 36y. So do as I say, not as I do. All right, so we, in this case, are going to actually move the y term as well over to the other side. So we would then change our signs, getting 3y squared on the left, positive, and negative 36y on the left, and we change that positive to a negative because we moved it over. And similarly, we can move our x term to the other side to join the constant there. So we would now have that left side equaling the right side, where x is now negative, and we still have this negative 92 where it was. So at this point, if I wanted to begin to continue the process of getting standard form here on the left, I would need to factor out the coefficient of the squared term. So factoring out that 3 leaves me with y squared minus 12y. Now I can leave a little space because I'm going to need to complete the square, so feel free to leave a little space there. And on the left side, we still have this negative x minus 92. Now what you could notice here is that they both have a negative in front, and eventually you might want to pull that negative out, but I'm going to wait until I've added a constant to the other side by completing the square. And then I'm going to pull out any common factors. Okay, so let's complete the square now, remembering that to complete the square here, when you have a variable squared and then you have a coefficient of the same variable and you're looking for the constant third term, you take half of b, which is the coefficient of the non-squared variable. So half of negative 12 is negative 6. And if you square negative 6, this is b over 2 squared. Squaring negative 6 times negative 6, we get positive 36. But if I put positive 36 right inside here, what have I really done? If I put positive 36 right there. Well, that's really eventually 3 times 36, isn't it? Which is positive 108. So I've really added 108 to the left side of the equation by putting 36 in parentheses there, which means I have to also add 108 to the right side of the equation. Now I can notice that I have a new constant on the right side. So on the right side, I now have negative x plus, what's 108 minus 92? That would be what? Positive 16. Good job. On the other side, I still have, so that was that positive 16 right there. On the other side, I still have 3 in front, but I can now factor this trinomial. We created a perfect square trinomial by completing the square carefully. We'd have y minus 6 times y minus 6, or y minus 6 squared, equaling negative x plus 16. Now don't forget about that 3 that came on down from factoring out at the beginning. We're almost in standard form now. One thing I could notice is that I need to get rid of the 3. Before I do so, I would recommend any coefficient of x, factor it out right now. The only coefficient is a negative 1, so if I factor out a negative 1, I would have negative 1 or negative sign, parentheses, x, what would the sign here need to be? Would it be positive or negative? Negative, correct, because a negative times a negative when you distribute is that positive 16 we had. The reason I would do that is because you can probably see what I'm planning to do in the next step. I would like to get y minus 6 squared by itself, so I would need to divide by 3. If I do that, I would also divide by 3 on the right. So I would now just have y minus 6 squared on the left side equaling negative 1/3 parentheses x minus 16. This is our equation, and you could definitely check in a graphing calculator or desmos.com how to graph that, but we're going to then try to prove it ourselves as well as we go along. So once we have the actual graph in what we call standard form, this is our y minus k squared equals negative 4p x minus h. So that's what we call the standard form of a parabola that opens how? That's a parabola that doesn't open up or down, but rather left or right, because y is being squared, not x. Then I noticed that because it's y being squared and we have a negative 4p, that's going to tell us we are opening to the left. So this opens left. So now I know the orientation of the parabola, and we also can read off the vertex. That's right. So our vertex here, according to standard form, is HK. So the HK that we see here, this H and this K, would be 16, 6, wouldn't it? So that should be the point furthest to the right, since it's opening left, furthest to the right, the most extreme right point of the parabolic trajectory here. So if this is 15 on my graph, I could go to 16, and if this is 5, I could go to 6, and somewhere yonder over here would be my vertex. Okay, so my vertex is located at the point 16, 6. I also know how it's opening. The graph is opening to the left. So something like this is happening, but we don't know exactly how wide or how narrow to make the parabola until we have our focus and our latus rectum. We could also use y-intercepts because I can see eventually that this graph will have to cross the y-axis 2 times. So I could actually let x equal 0 in my model, and I could get y-intercepts to get a better sketch as well. Now, if you're asked to find the focus and the directrix, what you really need to find is the letter P, right? Because P is our distance from our vertex to our focus and from our vertex to our directrix. So we need P, but we notice that 4P is seen here in the model as 1/3. So we use the fact that 4P equals 1/3. That also happens to be the total length of your latus rectum. We'll keep that in mind. If we want to get a couple of other points later on. So if 4p is equal to 1/3, what does that tell me about p? What is p then, using basic arithmetic? Divide by 4 really means multiply by 1/4 on both sides. So p would be 1/3 times 1/4, or really 1/12. So I need to go 1/12 unit to the left, since we're opening left, of my vertex, and I would hit my focus. So my focus would be, let's grab another color here. My focus would be a point 1/12 unit to the left of the vertex. Well, to the left means I start at the x value 16 and I go 1/12 to the left of it. So that's really just subtraction, 16 minus 1/12. So if I did 16 minus 1/12, that's really 16 times 12, or 192 over 12. That's the same as 16, isn't it? Minus 1/12. In other words, 191 over 12. 191 over 12 is the same thing as 15.19, I think I said that backwards, 91, I apologize, you can check your calculator here. 916 repeating. If you rounded it maybe to 917 roughly. Okay, so this is where I need to be. This is how many units I need to go from the origin, of course. Okay, so I'm talking about at the vertex. If I go 1/12 to the left, this would be the new x value of my focus. So the exact fraction would be 191 over 12, but the actual y value is still at 6, isn't it? Still at 6, because you're starting at your vertex and you're moving 1/12 to the left. Okay, so showing that on my picture, that's not very far at all. So if this was 16, I'm not even at 15. I'm really, really, really close. This is where my focus would be, right? It's kind of hard to see that because it's so close. What about my directrix? Well, the directrix would be a vertical line behind it, right? So to find the directrix in this case, it should be x equals something if it's a vertical line, okay? And it should be 1/12 of a unit to the right of the x value of the vertex, 16. So if I go 16 plus 1/12, that again would be 192 over 12 for 16 plus 1/12. So I'm getting 193 over 12. And 193 over 12 is the same thing as 16.083 repeating. So it turns out that the directrix is at x equals 193 over 12, also known as 16.083 repeating. So that's going to be right behind this vertex. That's my directrix, D. So I have a situation where you could zoom in, if you have time, that the vertex is here at 16.6. I go to the left 1/12 of a unit, so now I'm at 191/12, 6, and I have my focus. Or I go 1/12 of a unit to the right of that vertex, and I get 193 over 12, which is the same as 16.083 repeating, and that's going to be that directrix. So now I have a better idea of what's happening, but if I really want to know how wide or how narrow to make this parabola, I could use the endpoints on the latus rectum to get 2 easy points. Now, where are those points typically? Those are points which are parallel to the directrix and on the line segment that cuts through the focus and is still on your parabola. So what we have to notice is if we have 4p, it's our total length of our latus rectum, it's 1/3. So instead of going up a full 1/3, I need to recognize that the total is 1/3. So if I cut that 1/3 in half, if you will, I would get 2p in each direction. So what is a third cut in half? Well, that's a third times 1/2, which is 1/6. So I should be going up 1/6 and down 1/6 from the focus. Another way of looking at this is saying 2p in each direction. So 2 times 1/12 is 2 over 12, which is 1/6. So 2p in this case is 1/6. I noticed that. Either by cutting 4p in half or by doubling p itself. So if 2p is 1/6, I'm going 1/6 above the focus and 1/6 below the focus to get the endpoints on my latus rectum. So starting at my focus, so I'm looking for these endpoints on the latus rectum. Endpoints on my latus rectum. In order to get these endpoints on my latus rectum, what I would need to do then is start at my focus and go up and down, so that y value for the focus of 6 right here needs to go up and down by 1/6 unit. So I start off at 191 over 12 because that was the x value of the focus, and then I take the y value, which was 6, and if I take 6 and add or subtract 1/6 to it, adding and subtracting 1/6 to 6, what does that produce? Adding and subtracting 1/6 to 6. Well, 6 over 6 is really 36 over 6. If you take 36 minus 1/6, you get 35 over 6. On the other hand, if you take 6 and you add 1/6 to it, that's 36 over 6 plus 1 over 6, which is really 37 over 6. And you can put these in your calculator, and you should get, for this one, 37 over 12. Oh, sorry, over 12 for some reason. I meant over 6. Sorry about that. 37 over 6. You should be getting for that number 6.167 if you round. And for 35 over 6, you should be getting 5.83 repeating. Okay? So you can see now that 5.83, it's right above the focus. 5.83 is just barely up here. And right at the focus, go down 1/6 of a unit, you should be at, sorry, this one was 6.16. This one should be at 5.83, so right around here, okay? So very, very, very small parabola opening up here. So something like this is happening. If you wanted to continue getting a better sketch, you could get any random point by putting in an x value into your model. Remember, here is your model. Y minus 6 parentheses squared equals negative 1/3 parentheses x minus 1 over 16. You could put any x value in here and it should spit out a y value to get more and more points. If, for example, you wanted to find the y-intercepts, you could let x equal 0 and then solve for y, and I believe you should get 6 plus or minus 4 over the square root of 3. So check that out on your own. If you try y-intercepts, you should be getting 6 plus or minus 4 over the square root of 3. Which you could definitely rationalize as 4 square root of 3 over 3, and I believe you end up getting nice numbers around, let's see where they look like on my graph here. I'm looking at my Desmos real quick, and you can check yours out too. those numbers turn out to be, let's see, sorry I'm so slow here. Zoom out, zoom out. Okay, here we go. 8.309 and 3.691. 8.309 and 6.391. So those would be your y-intercepts, and you could put those on your graph and get an even better sketch. So that would help you to continue to get this picture even clearer. So that would be the idea here. I said 3.691. Wow, sorry about that. That wouldn't make a lot of sense. I was thinking, that seems a little bit high. 3.691, that makes more sense. So 3.691 would be around here somewhere, and 8.309 should be around here somewhere. So I could get a better sketch that way. Okay, so I've done a very, very basic, kind of gross looking sketch. Apologize for it being all smushed together, but I wanted to go ahead and go through the process of how you use completing the square to get standard form, how you then read off your vertex, understand how it opens based on y being squared and 4p having a negative in front of it, finding the vertex from the model, and then understanding what p does to get you to your focus from your vertex and to get you from your vertex to your directrix. Again, the length of the lattice rectum is the length of the line segment that cuts through the focus and is parallel to the directrix. So if the total length of that is 4p, you had to go 2p up and 2p down from the focus. So that's why I started at that y value of 6. I went up 2p and down 2p. Here 2p had to be 1/6 if p was 1/12. I hope that helped. If you have any more questions, feel free to let me know. I'm here to help. Happy practicing, because math is not a spectator sport. I'll see you next time.